Sketch the curve y equals root x. Describe the transformation that transforms the curve y equals root x to the curve y equals root of x minus 4. The curve y equals root x is stretched by a scale factor of 5 parallel to the x-axis. State the equation of the transformed curve. So here's the question in summary then. So let's do the sketch then. Let's paste in an axis here. So we can do the sketch y equals root x. So basically here we just have to sketch the square root function. Not very well drawn. I've got a digital pen, so I've used dashed lines, and this is y equals the square root of x. Okay, that's the first part then. Describe the transformation from y equals root x to this. So let's just sketch this function in. So when x is 4, we put 4 in here. 4 minus 4 is 0. Root 0 is what you get from this point here. So it's as though that point moves across 4 units to here, and then the curve would ensue here, wouldn't it? It would start here. Everything being moved by 4 units. It should go up a bit more than that. So there's the curve then. So part 2. It's a translation horizontally, isn't it? Plus 4 units. Parallel to, well, it's in this direction, so it's parallel to the x-axis. Okay, that's part 2. The curve y equals root x is stretched by a factor of 5 parallel to the x-axis. So instead of being shifted, it's stretched. Instead of being translated, rather, it's stretched by a factor of 5 parallel to the x-axis, so that would be in the same direction. So if we have a look at that, parallel to by a factor of 5, so the point that was on 1, say, this point here, which would be 1 as well, is stretched by a factor of 5 parallel to the x-axis, so it's moved to here. So this would be 5 and 1, wouldn't it? So what curve would do that then if we stretched it by a factor of 5? Basically we're going to come out like so, aren't we? And come out really flat like that. Okay, so this point here, so y equals the square root of x. Now to stretch it by 5, if we divide by 5, it's best to just put it down on the page. Let's see if that's correct. When x is 5, this point here on this curve, we get the value that we would get at root 1, wouldn't we? So it is x over 5. Had we tried 5x, we would see it was wrong. So you do this more or less by trial and error. Stretching, we put the number underneath by a whole number factor. Okay, so y equals the square root of x over 5, and that's part 3. Had we sketched y equals 5x, square rooted, just for a reference sake, we could try this or this. Well, we would see that if we put, to get the output from 1, we would need to put a 5th in here. So this wouldn't stretch it. This would stretch it, but by a factor of a 5th if we had this, wouldn't we? So stretching by a factor of 5, we need to put the 5 underneath in the resulting curve.